Why is NASA keeping an eye on objects near the Earth? Have you ever wondered why NASA keeps an eye on the objects around the Earth? Aside from the knowledge that comes from studying these objects, NASA also studies them to protect the Earth itself. To understand how exactly NASA does this, it's important to first understand two of the main space rocks found in the solar system. But before we dive deeper into the near-Earth objects, do hit the subscribe button on our channel and click the bell icon to be notified about more interesting videos. Asteroids. The Center of Near Object Studies track various types of NEOs, and details of some of these have been gathered. The first is the asteroids. When the solar system was formed about 4.6 billion years ago, rock fragments left behind during the formation are known as asteroids. Out of all the asteroids, the majority of them are known to orbit in a belt around the Sun between Jupiter and Mars. Scientists studying this belt have been estimated there to be billions of these asteroids, which vary widely in size, from about less than 1 kilometer, a bit more than 1/2 mile, wide to hundreds of kilometers across. Sometimes the orbital paths of asteroids can also become influenced by the gravitational tug of planets, which can lead to altering their paths. Scientists also believe that a major role in the evolution of our planet has been played by stray fragments from previous collisions or entire asteroids that have slammed into the Earth in the past. Comets. Comets have comparatively fragile, small, and irregular-shaped bodies and are similar to asteroids, as they have also been left over from the formation process of the solar system. However, comets form in the outer solar system and are essentially icy dirt balls. Grit, dust, and particles from space are embedded into their icy surface. Comets have usually been observed to have elliptical orbits, which cut across the orbits of other planets, which leads them to very close to the Sun, but are then swung far away and often even end up way past Pluto. Comets with the largest orbits can take up to 30 million years to complete one orbit. Comparatively, comets that have a smaller orbital path can take less than 200 years to complete their orbit around the Sun, which also makes them more predictable as compared to comets with larger orbits. When the comets are far from the Sun, they are in the form of a very cold and icy dirt ball. However, when they approach the Sun, the surface of the comet brings to warm up, and all the volatile materials on the surface begin to vaporize. This vaporizing gas also carries with it some small dust grains, which combine to form an atmosphere of dust and gas, which when seen from the Earth can look like a bright trail. Similar to asteroids, scientists believe that comets also played a role in the evolution of the Earth during its formation billions of years ago. A theory has also considered that the comets have brought some of the variety of organic molecules and water to the early Earth. Meteors and meteorites. As asteroids travel through space, they occasionally collide with each other and break up into much smaller fragments. Comets also shed the dust that lines their surface as they travel through the solar system. The result of these break-offs is numerous small fragments and particles which are called meteoroids that orbit the Sun. The majority of these meteoroids are rocky and small. The shooting star is a result of when these meteoroids approach the Earth and begin to burn up as they go through the Earth's atmosphere. Larger meteoroids are called fireballs, which range in size from roughly around the size of a basketball to a Volkswagen. They also break into further fragments and create impressive sky displays, and they burn up while going through the Earth's atmosphere. The Center for Near-Earth Object Studies, CNEOS, the Center for Near-Earth Object Studies, is located at the Jet Propulsion Laboratory and is managed by NASA. The center is responsible for studying all known near-Earth objects, for accurately characterizing their orbits, and for predicting how close to the Earth they will approach. The center reports comprehensive impact hazard assessments, which go on to support the agency's Planetary Defense Coordination Office at NASA headquarters in Washington. JLP manages the Center for Near-Earth Object Studies for NASA and tracks all asteroids and comets that drift close to the orbital neighborhoods of Earth. What are near-Earth objects? Any object such as a comet or an asteroid can be classified as a near-Earth object, or a NEO, if it comes close to our planet, by less than 1.3 times the distance of the Sun from the Earth, with the distance of the Sun from the Earth being about 93 million miles. They can also be classified by orbit size, with their orbits being within 120 million miles, that's 195 million kilometers of the Sun. This is enough distance for them to circulate within the Earth's orbital neighborhood. Out of all the NEOs, the majority of them pose no threat at all. However, it's a small percentage of that amount that are potentially hazardous asteroids, and those are the main subject of scrutiny. These objects are calculated by approaching the Earth at less than half the Earth's sun distance. Most of the near-Earth objects are asteroids that vary in size from about 10 feet, that's a few meters, to almost 25 miles or 40 kilometers across. With the threat the NEOs hold for Earth, our engineers and scientists are working on plans to develop diversion tactics and for a proper warning system to be used in case any NEO asteroids could ever cross the orbit and endanger the planet. The CNEOS is a continuous monitoring of all NEOs that pose as an impact risk, computing the orbits. The orbit of each object can easily be computed by members of the center by finding an elliptical path going through space ideally fits all the available observations. This path can also span many orbits over a time period ranging from many years to decades. With time and advances in the observations being made, the accuracy of the observation of the orbit of an object has improved dramatically. It has now become possible to easily predict the future location of an object after years or even decades into the future. This helps us estimate whether the said object could come close to the Earth and pose as a threat or not. The Minor Planet Center databases. The databases at the Minor Planet Center act as a clearinghouse for all position measurements of small bodies and are also internationally recognized. All the orbital positions of the near-Earth objects come from their databases. Observations from all around the world combine to form this data and also include observations from amateur observers, which are significant observations. However, the vast majority of the data tracking asteroids is collected by large observatories that are funded by NASA itself. These include the Catalina Sky Survey, NASA's NEOWISE mission, Pan-STARRS, and the NEO Surveyor is also set to become one in the near future. JPL's Goldstone Solar System Radar Group and other planetary radar projects by NASA are another major component of the NEO observation program by NASA, predicting the future. The home of the Sentry Impact Monitoring System is the Center for Near-Earth Object Studies. This system is responsible for performing continuous analysis on a long-term basis of all the future orbits of all possible hazardous asteroids. For the next 100 years or more, based on current observations, there is no known significant threat of impact. A scout system is also maintained by the center, which continuously monitors the potential of all brand new near-Earth objects being detected. This is done even before the confirmation of their discoveries comes through, and this allows them to see whether any of these NEOs, which are mostly small asteroids, pose as a threat of possibly imminent or short-term impact. Impact response exercises. NASA's planetary defense efforts are also supported by the SNEOS, which leads exercises for potential impact to help educate the disaster response agencies internationally as well as nationally on the account that they would know how to respond to the event of an actual asteroid impact scenario. These exercises help by informing the key decision makers and the scientists about all the warning systems and all the strategies to mitigate possible impacts and how to employ them in the event that a threatening object is identified. NASA, along with various other organizations, have made it a part of their mission to study, observe, and research all the life outside this Earth. One major part of this research has been the observation of the near-Earth objects to predict the orbits of the ones already existing as well as the ones that are being discovered. This has helped ensure that the Earth remains safe from any incoming possible hazardous objects, such as the ones that have been estimated to have happened billions of years ago, playing a vital role in the evolution of our planet. Now we know why NASA keeps an eye out on all the objects around the Earth.